The manager of a customer service center wants to know the ratio of abandoned customer calls for potential improvements in the system. A simulation model will be created for so. How could we build it in Plain Simulation? Hello, this is William, and today I will create a model of a customer service center in Plain Simulation. The idea is to share the model creation process with you, so it's not necessarily a tutorial. I'm just showing a certain way to achieve the objective since there are many strategies for so. If you're interested in Plain Simulation, in other discrete event simulation tools, or if you're planning to start in the simulation field, this video is for you. I hope you like it, and let's get started. First of all, let me show you the model input parameters, assumptions, and metrics. For the input parameters, the average time between customer calls is 4 minutes based on an exponential distribution. The number of customer service representatives available to handle customer calls is 5. I'll call them CSRs. The average service time per customer is 8 minutes, also based on an exponential distribution. There's one more parameter that is the maximum waiting time of 10 minutes, or the customer's patience. The simulation should run for 9 hours to represent a workday. For the simulation metrics or KPIs, we have the average time customers spend waiting in the queue before being served by a CSR, the percentage of calls abandoned due to exceeding the maximum waiting time, and the percentage of time each CSR is occupied with handling customer calls. Lastly, the simulation assumptions. The customer service center operates efficiently with no CSR downtime or other factors causing delays. The CSRs have a constant level of efficiency throughout the simulation, so there are no failures. Calls are answered in the order they arrive. It's the first in, first out queue discipline. Now that you know what the model refers to, let's head to Plain Simulation. Okay, so here's Plain Simulation, and let's start to create a model. The first thing I'm gonna do is define the customer call class so the model gets closer to the scenario in question. The part class will be used as the template for so. Now let's create a source for customer calls on the frame. I'll name it customer call source and we'll set its interval and start parameters to 4 minutes in average based on the exponential distribution. Let's drag the customer call class to this source accordingly. In order to model the 5 CSRs, I will use a parallel station block instead of 5 station blocks. In case we had to model failures at CSR level, I could choose another solution for that, maybe with the stations. I'll enter the number of 5 CSRs and set up the parallel station to work even when not full. The processing time is 8 minutes in average, again based on the exponential distribution. Now let's add a drain block to the model so that finished calls are discarded from it. I'm going to call this finished calls. Now we have to connect the blocks. I'm going to limit the simulation time to 9 hours since that's a parameter. There's no need to set up a warm-up period since it's a terminating simulation. If we run the model now, it's possible to see the customer call flow working correctly. Let's add a few displays to see the numbers. I'm gonna add one for the customer call source and another for the CSRs. Let's get the correct CSRs attribute to be monitored. When the model runs, we can see the two numbers match. That indicates all customer calls have at least started to be processed by the CSRs. Now let's add the queue to the model. We know that if a call cannot find a free CSR, it will wait in a queue until its turn. The detail here is that the customer will hang up after waiting for 10 minutes without being served by a CSR. With that said, I'm going to add a buffer to the system. Let's connect the buffer to the other components. I'll name it waiting calls and let's set its capacity to -1 so it does not have a limit. In this case, the buffer type is queue. It's the first in first out discipline. I'm forcing the customer calls to head to the buffer only if necessary. I can make sure of that by setting up the customer call source exit strategy to 100% while there is a slot for calls in the CSR's block. If we run the model again, we can see the queue is being used too. 33 customer calls have entered it. Now I'm adding the most different feature of this model. Currently, the customer calls that have waited for 10 minutes are still following the regular flow in the system. So let's create a way for them to leave it when that period gets expired. Let's add a new drain to the frame just for those cases. So this one will be named abandoned calls. Since the customer calls depend on time to either stay or leave the system, there should be a way to keep track of the waiting time for each of them. I see a few ways to accomplish so, but I will follow this approach. Since the waiting time for each customer call starts being counted when it reaches waiting calls, let's define a rule at this step of the system. I'll create an entrance control that makes the customer call wait until it's served by a CSR with a limit of 10 minutes. I will enter 600 because it's measured in seconds, and it will head to abandon calls if that time gets expired. That will happen for each customer call that enters the waiting calls queue. Now I have all basic components in the system. Let's create a display for the customer call average waiting time. A chart for the occupation time of the CSRs, and a variable to calculate the percentage of abandoned calls, named vAbandoned calls ratio. In order to calculate vAbandoned calls ratio, a method will be executed when the simulation run ends. Now that we have all set, the analysis may be carried out accordingly. Let's run it again and see the results for this particular run. The average time is 5 minutes and 15 seconds, the percentage of abandoned calls is about 3.1, and the utilization of CSRs is close to 90%, quite high by the way. That concludes the modeling process of the Customer Service Center under the conditions proposed. As we can see, that model is a quite simple example of a queuing theory system with just a few blocks in it. When customers give up the waiting time and their calls are abandoned, a little bit of challenge is brought to the model. And that's the coolest part, as there are different ways to solve it. It may not be that obvious in terms of modeling, especially for those new to plant simulation. Do you have questions on details seen in this video? Please feel free to share them. Let me know if you have other ideas to solve that problem, or if you have other scenarios to be modeled and featured here. I'll be happy to see your opinion and suggestions in the comments. Also, drop your like and subscribe to this channel. I'll see you soon.